Crimsalytics recently launched the Red Line Burndown for Jira Cloud. My name is Sharon, and I'm going to show you how to use it. Start by clicking the Edit button on a Jira dashboard, then type in the name of the gadget, then select the Crimsalytics Red Line Burndown gadget. We're looking at a development server, so there are multiple instances of our burndown gadget, whereas your instance will just have one. Once the gadget is added, the configuration immediately appears. You have the option to choose between story points or time-based burndowns. Jira Cloud projects support one or the other. The time-based mode relies on Jira's time tracking feature. Enter a JQL query to define the Jira issues that will be used to compute the burndown. In our case, we'll start with our test project, which has roughly 250 issues. Once we enter the JQL, the only other thing we're required to do is specify a start date for our chart. We'll pick August 1st, so that we can see how the backlog has been built over the last several months. Once we hit Save, the burndown chart will be computed and progress will update as the software works through the various phases of computation. All calculations occur within Atlassian's compute infrastructure, aka runs on Atlassian, as we built the gadget using Atlassian Forge. This means that you don't have to worry about a third party having access to your data. Crimsalytics does not have access to your data. Also note that the software caches prior computations to speed up future calculations. The cache is stored using the Atlassian Forge storage module, which again means that your data stays within Atlassian's ecosystem. After the computation is completed, the red line burndown is displayed. We'll hide the yellow estimate accuracy series so that we can see the green remaining story point series. Note the blue series is the number of points accumulated. In story points mode, the points are accumulated when an issue's status changes to one of the done statuses. Let's make the burndown a bit more interesting by adding a resource model. Within the configuration, the first field to set is the plan anchor, which ties the resource model to the green remaining estimate line. While the majority of this project is complete, let's assume we finalize the plan on November 19th, so we the plan anchor to that date. Next, we can set the budget, which is used to draw a horizontal line on the chart. The budget line is a very simple way of establishing a capacity for the period of time represented by the burndown. For the purposes of this example, let's set it to 1,600 story points. Discovered work allows us to shift the resource model up or down by the percentage entered. It's useful when you want additional padding in your plan. We'll start with a value of 10%. Utilization error defines the error bars that are placed on the resource model. Let's use 20%. Lastly, we'll configure the resource model. This is done by first defining a date. In our case, let's assume we started on September 2nd with 10 developers who are each completing 3 story points per week. Let's assume that towards the end of December, several members of the team took vacations, so we'll reduce our resource model to 5 developers and perhaps 2.5 points each. Then, in early January, we'll go to 9 developers at 3.5 story points each. The black horizontal dashed budget line acts as a baseline for our capacity for a given period of time and gives us the ability to iteratively build a backlog and see how the resource model and backlog compare to our fixed capacity. The resource model adjusts at each of the dates we entered, where the slope of the resource model matches our collective velocity, which is the number of resources times the per resource velocity. For example, this first point shows 10 FTEs at 3 points per week, resulting in a velocity of 30 story points per week. Note at the very end of the tooltip, we calculate the actual velocity for this period of time. Again, this is test data, and our actual velocity is actually negative, meaning we're adding more points to the backlog than we're completing. The discovered work value of 10% that we previously entered shifts the resource model up by 10% of the remaining backlog on the plan anchor date. This can be used to add additional buffer or negative buffer into your resource model. The utilization error of 20% that we defined creates this shaded pink region around the resource model. We can look at the date when the low, model, and high values hit 0 to get a sense of the range of possibilities for completing this body of work. Now that we have our resource model dialed in, we can monitor the progress of this project by examining the velocity. If the project is on track, the velocity should stay below the red line and remain on that trajectory. If the project is heading off track, The velocity will appear to be on a path to cross the red line, and we should meet with the team to understand how to address this as soon as possible. For example, when the green line was heading into the red line in this region, the team was on a path to cross the red line. In retrospect, we observed that the team made some changes and their velocity improved. Since we're on the topic of velocity, there is also this purple series that shows the average team member team velocity. The calculation uses the resource model to determine the number of resources that were available for that week and the green line to determine the velocity. Negative values suggest more points were added than removed from the project, and positive values suggest more points were removed than added. The Red Line Burndown also has a prediction feature that does a least squares fit of the last n days of data. In the configuration, you specify the number of days to use. Let's set our burndown to use the last 21 days to predict the end date. And the prediction line is drawn as a green dashed line, extending the burndown until it hits 0. I'm going to pass this over to Max to take you through the next set of features.
Thanks, Sharon. Let's switch to a time-based example to take a closer look at this and some other exciting features. This is a much simpler project with only a few issues. One thing to note here is that this resource model shows that the team basically took the entire month of January off, as the resource line for that month is horizontal. Through the configuration, we've set up some additional burndown series, and those are appearing with different line styles. A chart supports up to 5 additional series each, of which has a separate JQL query that is combined with the original query using the logical AND operator. This effectively creates a secondary series that shows the subset of issues that match the original query and the new query. You can add a label to the query. Some examples of additional burndowns are 1. Reviewing how different priorities of work are progressing, as shown in this chart. 2. Looking at different milestones, assuming those are queryable through JQL. 3. Comparing Team A versus Team B. 4. Looking at different issue types, such as bugs over the course of the development effort. To summarize, this feature lets users visualize how each of these components is affecting the overall project. While we're reviewing this chart, let's take a look at the Analyze Burndown Changes feature. Before we do that, we'll hide all the series and just turn on the primary series. One of the biggest challenges reviewers of burndowns face is that it's extremely difficult to figure out why the chart looks the way that it does. For example, we have that sharp spike up of the green remaining estimate line on December 26th. In this case, it looks like it was just part of the plan. However, imagine this was a spike in the remaining effort line halfway through a critical project. In order to figure out what happened, you'd need to write some JQL to see which issues were modified around those dates, and then look through them one at a time. Instead, with the Red Line Burndown, you can simply zoom in on the area of the chart in question and then filter the Analyze Burndown Changes table to show the list of all changed issues in that period of time, along with the values that were changed. In this case, we see that 3 issues had a net change of 13 days of work. One great feature in this table is that all the columns are sortable, so if lots of issues changed in that period of time, you could sort them by change size and easily find the largest changes. If you want to dig deeper into an issue, simply click the link to open it and review the history. Next, we're going to dive into the metrics feature. Have you ever spent a ton of time reviewing a burndown, backlog, and plan, only to realize that a significant number of issues weren't estimated? Then while you're monitoring the project, the backlog just keeps increasing in size. You search for newly created tickets, and guess what? There aren't any. In reality, the team failed to estimate all the work, and now they're gradually going back and adding estimates to issues. To address this problem, we compute some metrics that are super helpful in understanding the health of the backlog. In addition to showing you how many issues aren't estimated, the chart includes the average estimate, total original estimate, and how many issues are in each state. Lastly, the red line supports the ability to download all the series data as well as the changelog data. This is your data, and we want to make it as easy as possible to perform any additional analysis. Lastly, the red line supports the ability to download all the series data as well as the changelog data. This is your data, and we want to make it as easy as possible to perform any additional analysis. Separately, you can quickly take a picture of the burndown, zoom, or pan. We appreciate your time and interest in the Crimsalytics Red Line Burndown. Great teams need great tools. You can find us at crimsalytics.com or in the Atlassian marketplace under Crimsalytics Red Line Burndown for Jira Cloud.